in the seminar. We have a good friend, former colleague of mine, Dr. Mike O'Driscoll, actually one-time Norfolk resident and a veteran. You can imagine which service. He is here to talk about groundwater, sea level rise, and implications in the coastal Carolinas. So a little bit of background. Of course, I overlapped with Mike for quite a few years at East Carolina, and he is still there. He is a professor in the Coastal Studies Institute, which some of you may have had a chance to or heard about visiting it on the Outer Banks on Roanoke Island. He does an extensive amount of interdisciplinary coastal resource problem solving, applied research. We've worked on Currituck. I remember, can't forget some work up there. But he's been on the faculty at ECU since 2004. He had been actually stationed in Norfolk on the USS America and served during the Gulf War. He had eventually, after his service, worked as an environmental consultant in Connecticut. He earned a Bachelor of Science in Geology from UConn, which is kind of interesting right now, NCAA and all. A master's in environmental pollution control and geoscience, and a PhD in forest resources at Penn State. So he's an associate director of the Carolina Water Resources Center at ECU. And just a great pleasure to have you here with us, Mike. We'll let you take it away from here, and we'll have some time for questions at the end with hard stop 4:30. Thank you.
Thanks so much, Tom, and thanks everyone for joining us this afternoon. So I'm going to talk a little bit about some of the data that we've been looking at how the groundwater is responding to sea level rise. This was a broader project looking at the coastal Carolinas. Today, I'm going to focus more in on some of the Dare County information. And just in case we run out of time, I wanted to just briefly go over an outline. But the main points I wanted to make is that we can notice groundwater level rising towards the coast in Dare County. And when you look at the septic systems in the region, we can notice that some of these systems are starting to become impaired related to that rising groundwater level associated with sea level rise. So when we look at some of our challenges in coastal North Carolina with respect to groundwater, one of the ones that you hear about a lot in the news is some of the declining groundwater levels related to groundwater withdrawals. We have noticed some subsidence and then also saltwater intrusion issues near the coast. So you may have heard about some of these challenges when we look at the groundwater levels in the deeper aquifer systems. This is an example at Kinston, North Carolina, the Black Creek aquifer, and you can see the groundwater levels have declined on the order of 60 feet over several decades. So with some of these challenges, the state started to reduce the withdrawals on these deeper aquifer systems. And then they created this management area called the Central Coastal Plain Capacity Use Area in 2002. One of the cool things with the management efforts, reducing some of the withdrawals on these deeper aquifers, is you can start to see the groundwater levels returning back to pre-pumping levels in some parts of the system. So they could see there are some improvements in our groundwater levels associated with this management effort. So just for basketball fans, they call this the rebound. What's interesting, if you look at the different aquifer systems, and so this is looking at some nested wells out on Roanoke Island. This is where Manteo and Wanchese is located. In the deeper aquifers where they withdraw water for water supply, what we could see is in the Yorktown aquifer, the groundwater levels are still declining. So there's more withdrawal than the natural recharge. What's interesting is if you look in the shallow superficial aquifer, so this can be 0 to 100 feet deep around. What we noticed is there's a rise in the groundwater levels in the superficial aquifer. So that's kind of what the system looks like if you look at our coastal plain aquifer system. And I'm going to focus on the groundwater level changes in the shallow superficial aquifer. This is the general sediments where our septic system discharges go into. But one thing that's happening out on Roanoke Island and out on the Outer Banks is we're taking water from the deeper aquifer system, and then we use that in residences, and it discharges, that wastewater discharges into the superficial aquifer. And so what we can see is there's artificial recharge that's going on. Basically, we're pulling water from the deeper system and then we're adding it to the shallower system. So we kind of have mixed messages. If you try to tell people, well, our groundwater levels are rising, it depends on what aquifer system you're looking at. They're declining in some of the deeper aquifer systems associated with water use, groundwater withdrawals. So fortunately, the state's been dealing, and they have a good management plan for dealing with the over withdrawals in the deeper Cretaceous aquifer system, basically. So they've been addressing this. It looks like there have been some improvements made. One of the challenges now in the shallower superficial aquifer for communities that are close to the ocean and the estuary system is they're starting to notice more drainage problems, right? So essentially too much groundwater in the system, and looking for help, basically, to help deal with these systems. Essentially what it looks like is happening is as sea level rises, the groundwater levels in the superficial aquifer system are also rising in communities near the coast. So a lot of the communities need help. And so that's part of this effort to try to help out. So one of the reasons that the changing groundwater levels is important when we look at these coastal communities that may be on septic systems is the main wastewater treatment mechanism for septic systems is the unsaturated soils. Basically, they can help to filter and remove bacteria and viruses. They can enhance nitrification. There's a lot of nutrients in the wastewater, and so by nitrifying, that can give the opportunity for denitrification to occur later in the system. When we look at field and column studies, they generally suggest we would want to have more than 2 feet of unsaturated soils to get adequate waste treatment for these on-site systems. The North Carolina rules for sandy soils, they ask us to have at least 1.5 feet of unsaturated soils beneath systems, right? So it's not perfect. You get some treatment. It can be pretty adequate, but a lot of the studies suggest we would actually want more unsaturated soils underneath these systems. And there's been some recent studies that show when you reduce that unsaturated soil zone, you start to lose some of the treatment capabilities that these systems are designed for. And so you can just imagine, naturally near the coast, we do have shallow groundwater levels. So it can be a challenge to even find areas sometimes where you would get adequate treatment with conventional septic systems. And so when the groundwater levels are rising, they can start to squeeze out the treatment, and you start to get over time a slow reduction in the treatment capacity of these systems. So when we look at North Carolina, we rely very heavily on on-site wastewater treatment systems. Typically, the conventional system is going to be a conventional septic system. When they look for the whole state, we have about 2 million systems currently in the state. About 1 million of these systems are in watersheds that drain to our coast. So we really have a quite large number of these systems. It works out to be about half of the residences in the state. are reliant on septic systems. This is the highest number for the southeastern US and the fourth highest in the country. So Sushma Pradhan works with Health and Human Services in North Carolina. She did a nice study earlier, just looking at where the systems are in the state, mapping them out. And one of the things that shows up in her GIS analysis is a lot of times our coastal communities actually have a higher density. So it's related to basically the density of systems that you need, the density of residences that you need for a municipal treatment plant. A lot of times our communities are more spread out near the coast. And so we don't have as many municipal treatment plants near the coast. We have a lot of on-site systems. Nags Head is one of the communities that we worked with on this project. And I'll just show an example. If you look at their septic systems, it's about a 6.6 square mile area for the town. They have over 3,600 septic systems in this area. So it works out to over 2 systems per hectare. And when you look at the density that it usually takes to start to see water quality impairment, it's usually over 1 system per hectare. So you can imagine there can be some water quality issues. And then just looking over time, we can see that the density is increasing over time generally. So because the unsaturated soils are so important to treating wastewater, in places where we have shallow groundwater and where the conditions are changing, they start to become more vulnerable. If these systems aren't working properly, it can lead to excess nutrients. A lot of times, these are in areas that are close to recreational or shellfishing waters. Some of the eutrophication issues, particularly on the sound side, can be important. And then you can potentially spread diseases if the viruses and bacteria aren't treated properly. So we kind of have 2 situations. You guys might have heard last year down in Rodanthe, a couple of houses just collapsed right into the ocean. But if you look at the picture, you can see that's their septic drain field and waves are crashing down on it. So that kind of acute situation is a public health hazard, and they're trying to deal with those kind of systems. The other issue is just the slow chronic rising of groundwater levels in these areas where you're slowly starting to reduce the treatment capacity of these systems. So we kind of have to deal with that slow rise in groundwater level and also the coastal storm impacts. And so I think y'all are pretty aware of us being located in an area where relative sea level rise is rising a little bit faster than some of the other areas on the Atlantic coast, particularly for the northern part of North Carolina, northeastern North Carolina, and then up into the Chesapeake Bay area. One thing that's helpful for us for this study is Duck has a sea level rise gauge there that's been maintained by NOAA, where we can get pretty good estimates of the relative sea level rise in the region. It's about 5 millimeters per year. And when they project forward, looking at about a meter rise by 2100. So thinking about these communities where we have septic systems and what the impacts can be in the future. So this is the area I'll focus on for today's talk, basically looking at Dare County. And then we really focused in on Nags Head for some more detailed information. But we wanted to see how sea level rise is influencing the groundwater levels here, how these groundwater levels respond to coastal storms, and then what the implications for the on-site wastewater treatment systems are. The orange square wells, these ones are really powerful. They were set up by the Department of Environmental Quality back in the 1980s. So a different frequency of data collection. Starting around the 2000s, around 2004, they started to get daily data collection at a lot of the sites. So I'll show you some of that data, just looking at longer term trends. And then the green wells are wells we put in place in cooperation with NAG's Head and the Coastal Studies Institute as part of this project. We put some wells directly into the septic system drain fields and then some adjacent. And then also the NOAA tidal gauge, having that information since 1977. I'll talk mostly about the groundwater level data. And then there's a little bit of information on some of the water quality data that I'd like to include just to kind of give you a picture of what's going on. So just to start, looking at the sea level rise information at Duck, North Carolina, and you can see that roughly 5 millimeters per year, longer term trend in sea level rise. When we look at all of the North Carolina DEQ superficial aquifer wells going back to 1983, if you just look at the average annual groundwater depth in the superficial aquifer, over time, what we can see, if you relate that to the mean annual sea level data at the duck gauge, we can see a relationship. And basically what's happening is as sea level rises, the groundwater levels are rising in Dare County. And so this is a little bit more detailed information. If we use the daily data at sites where they have daily groundwater level collection at the individual wells, these are the 5 best wells for the longer term record. And basically at the daily sites, what we're seeing is, so this is looking at groundwater depth. When it's pointing up, it's showing that the groundwater depth is shrinking over time. So the groundwater levels are increasing, and then the groundwater depth, it's getting closer to the land surface. For the mean annual groundwater level rise with these sites with daily data, we were getting about a 10.6 millimeter per year average. So it's kind of interesting. We think the reason that this is a little bit higher than the sea level rise rate is because we're using water from the deeper aquifer, and that's artificially recharging into the superficial aquifer system. And people have shown this at other sites where you have a water source that's coming from outside of the area and you use it in homes, septic systems will recharge some of that groundwater. So this is one of the sites where it looked like it was starting to become problematic. This is at the Wanchese Community Center. They have a septic system at the site. And this is located just a few miles down the road from the Coastal Studies Institute on Roanoke Island. These are the longer term groundwater depth data for that DEQ well in the superficial aquifer. And so what we could start to see is that back in the 1980s, typically the septic systems will be buried about 1.5 feet deep or so. So kind of a 0.5 meter where those systems will be buried. To get the state's requirement to have that about 0.5 meter of unsaturated sediments underneath the system, you want to have more than 1 meter groundwater depth. So I kind of shaded that in here so you could see. Basically, back in the 80s and 90s, there was more time when the system would be suitable. And then as you get to the more recent decades, groundwater is going to be up in the drain fields in this area. So we could notice that trend in these wells and the groundwater level data and the depth data. So this is looking at the storm response at the Wanchese Community Building superficial aquifer well. And this was looking for a larger rainfall event, just to look at the conditions after you get an extreme event. This was a 7-inch rain event in October 2012. And if we kind of think about having 1 meter depth as something that's suitable for our systems, what we noticed is the groundwater level rise from this extreme event was over 1 meter. And if you look at the recession, how long would it take to get that groundwater deep enough where the systems would be more functional again? And so it looked like if there's no other rainfall, just to get the groundwater back to the pre-event level, it can take something like 100 days for one of those extreme events. So that would be a time frame where the systems aren't working as designed. Because they had a lot more rain later in the season too, the groundwater levels stayed pretty close to the surface for about 6 months after that event. And so when we looked at different large rain events, anything over about 5 centimeters for this site, what we could see is it typically will take on the order of weeks to months for the groundwater levels to return back to pre-event levels. So you start to think these systems are not functioning as designed. It can be sometimes for several months after a large event. So this is kind of the dirty secret at the coast, is that these systems, when they're permitted, that's the time when they actually look at the systems. But after they're installed, typically there's not monitoring or any further look at these systems. So there's a lot of systems that, as the groundwater rises, if you don't see visual signs at the surface, they may not be monitored, or there may not be any corrective actions to help out these systems. And in Miami, they've had this kind of problem. They sort of started to categorize these into compromised and failed systems. Compromised would be just not having as much unsaturated soil beneath the system as they were designed for. And then failed would be if the system's actually flooding from groundwater rise. So for those of you, if you like Dexter, just thinking about what lies beneath the surface in these areas, if you can't see it, sometimes there can be trouble. And here's an example. One residential site, a very kind homeowner let us monitor this site. And then the other site at the Bonnet Street beach access in Nags Head, we had gotten permission from Nags Head to monitor this. If you look at these are both images of the drain fields, and you can't really tell just from looking at it. You might not be able to smell it. You might not be able to see it if the system isn't working properly. This system we found after monitoring it, it's failing. It's being flooded by groundwater. The beach site was actually working pretty well. So much deeper groundwater in that Bonnet Street beach site. So these are some of the signs. There's examples where you can see wastewater upwelling at the surface. The first image there. Sometimes you can see it in the drain field and you know you have a problem. So typically those situations, or if wastewater is backing up into the home, those situations will be dealt with. There's some other more subtle signals, like when you see the really green grass over the drain field, that can give you a hint that not all the water is draining away from the system. But this site here that we found was being flooded by groundwater because the soils are so sandy, it's pretty well drained. You don't really notice it at the surface. And this just shows when we looked at all the groundwater records for 13 different sites around the county, about 8 of the sites, it would look like the groundwater is typically shallower than 1 meter. So these would be areas that we would be concerned as far as functional septic systems. And that tended to correspond with about 2.6 meters or 8.5 foot of land surface elevation. And I'll show an image next sort of where that information came from. And then at the bottom of the figure here, I'll work through this in a little bit here. But at the bottom of the figure is showing some of the sites that are at higher elevation, and those tended to have pretty deep groundwater, relatively deep anyway, where the groundwater would typically be greater than 1 meter. So when we looked at the land surface elevation for these longer term wells, what we could see is there's a pretty decent relationship. You can get a rough idea of sites you'll have problems with as far as where the groundwater table on average will be if you compare the land surface elevation here in Dare County. And what we noticed is the northern part of Nags Head, there's a lot of higher dunes up in that area. The elevation is generally higher, so you'll tend to have a deeper water table there. And as you work your way down to the south part of Nags Head, that's where the groundwater is much closer to the surface. The land surface elevation is a little bit lower. The other areas that are reason for concern would be on the sound side. There are some pretty low-lying areas there that can have pretty shallow groundwater. So in green at the top of the figure, Body Island is one of the DEQ long-term sites, and we can look and see the groundwater level variability there over time. It's typically within a meter of the land surface. In blue is the South Nags Head private residence that we monitored, and it was typically within 1 meter of the surface for most of the year. And then at the higher elevation sites in northern Nags Head, we could see a deeper water table basically. So typically it's going to be below a meter or greater depth to groundwater. And so this is just looking at sort of the groundwater levels across Nags Head. And what we could see is down in the south part of the island, the groundwater is much closer to the land surface. So septic systems in that part of the town are going to generally have a little bit more stress on them because of that shallow water table. Same thing with the sound side areas up to the north. So down in South Nags Head, there was a really generous homeowner here, and this is Dr. Humphrey here. We were installing a well. She let us to install a piezometer in the drain field and do some monitoring at her system. Here we go. Sorry, it jumped through a few of the things. But basically, we wanted to look into the tank. We took some measurements in the tank. We put some loggers in to monitor the groundwater levels. And so the most important thing here is the septic systems are supposed to be gravity drained, right? So there should be the water trickling out of this pipe coming from the house. The wastewater should be below that. And what we saw at this site is it's above the pipe, right? So it indicates it's being flooded by groundwater. So it can cause problems in the homes, and also it can cause the wastewater to upwell in the drain field. So public health hazard. So this is looking at the groundwater level data in that particular system in South Nags Head. And the blue line showing the changing groundwater depths over time is showing what we found during the period we were studying. We started in November 2020. The dashed blue line there is showing the depth of her drain field. And so you can see the groundwater is in the drain field for most of the year. It was about 70% of the time that drain field was inundated by groundwater. We used the groundwater level rise rate in that area to look at what it would have been like back in 1988 when the system was installed. And it still would be questionable. The dashed line at the bottom is showing basically the state standard for vertical separation distance. So based on the state rules, you would want the groundwater to be deeper than that line. And so if we look back in time, it's not likely that it was even when they started, but there were periods when it was much drier. So at least it was below the drain field. If we look at the black line at the top, that's projecting forward to 2050 with the current rates of groundwater level rise. And so there would be the chance by then that the groundwater level could rise up to the land surface. So it could be mixed with waste and cause some problems. And then just looking at some of the projections for this area in the future. So this would be with a projected 3-foot sea level rise. You start to see that this area would be particularly vulnerable looking up at the neighborhood where that system is. So people have started to document this kind of problem. This is sort of what the situation can look like when the groundwater is rising up into the drain field, then you're losing the unsaturated soils for treatment. And I'll go through, let's see, for timing, I think I'm all right for now, but I'll go through this a little bit quicker. Basically, Dr. Humphrey and a group of us were monitoring in the drain fields and taking wastewater samples from the tanks and looking at how well these systems treat nutrients and also bacteria. This is just an example for the nitrogen data across these systems in Nag's Head. And they can work reasonably well if you have enough unsaturated soils. If you account for dilution, the numbers start to get a little bit lower compared to municipal treatment systems. And Charlie also did some work sampling some of the municipal wastewater treatment systems around to kind of look at what levels of treatment they were getting. But the best treating site for Nag's Head was that site I showed at Bonnet Street Beach. It has a much greater vertical separation distance, so it's kind of up on some pretty high dunes there. Nag's Head has been collecting water quality data at a range of sites, groundwater and surface water sites throughout the community since 2011. And one of the metrics that they've been using is looking at nitrate, because this can come from septic systems. And I just wanted to show some of the patterns from this longer term data set. When we look at that residential site where we were finding that the system's being inundated by groundwater, this is pretty close to this Juncos Well site here. And that was one of the sites where they had the highest nitrate concentrations. And generally that idea that in the area where you have the shallowest groundwater table, that it can start to stress the systems and get you less treatment. It kind of corresponds with the area that they're finding the higher nitrate concentrations in canals and also in the groundwater system. And we've done some work inland on some streams, like Falls Lake would be Raleigh's water supply in North Carolina. And this kind of pattern that they noted in Atlanta, where when you start to have higher densities of systems, you start to notice the nitrate showing up in the surface water. Typically, these studies have kind of shown once you get over about 1 system per hectare, that's when you start to see some of the water quality impairments. And Nag's Head would have about over 2 systems per hectare right now. So one of the things that Nag's Head has done is they created a decentralized wastewater management plan, trying to look at some of these issues and trying to account for places where the groundwater table is shallower, trying to evaluate risk to these systems. With this approach, they recognized about 11% of systems were at really high risk. So they like to target these for outreach and potentially considering changing over to more advanced systems. And other approaches they're using, they're looking at a voluntary septic subscription service possibly, but also just looking at ways to increase funding to help out systems in places where they're struggling. So if you're interested, the report came out last year and there's some pretty good information just looking at the rising groundwater levels and some approaches to try to deal with this. And then there's growing awareness. So you may have seen this article that came out last year in the Washington Post. Some of the challenges in coastal communities are documented, and they also talk about just some of the more intense rain in floodplain areas and more inland where people are experiencing more problems with their septic systems related to climate change. And Charlie Humphrey had a good quote here where one of the main points is a lot of our systems that were installed earlier, they may have met the regulations, but with rising groundwater now, they wouldn't meet the current regulations. Jane Harrison at Sea Grant and Lauren Voorhees, they conducted some surveys with septic system installers and operators in the coastal Carolinas, and also spoke with 8 regulators in the region, trying to get a feel for how people perceive some of these changes, what they're noticing in the field, and also if people are taking action to reduce some of the impacts that sea level rise and climate change can have on our systems. And so some of this work is published this past year in Weather, Climate, and Society. And I'll just go over some of the main findings, but with the regulators that were interviewed, they felt that the biggest challenge was the changing water table in these coastal communities as far as managing on-site systems. The other interesting finding from the operators and installers that they interviewed was that even though the rules don't currently account for rising groundwater levels, they found that when they talked to operators and installers, that some of them were being more cautious with systems that they permitted, trying to take some adaptation measures as far as rising septic tank elevations for permitting the systems, being more conservative. So trying to find areas where you have a deeper water table on sites to give you a little bit more of a protective buffer over time, recommending greater tank capacity, and then also recommending advanced systems in some areas where they're marginal. And one of the common factors that they mentioned is trying to use mounded systems in some of these areas where you can artificially increase the amount of unsaturated soils below the system by mounding the systems. So there have been several other studies documenting the rising groundwater levels along the Atlantic coast. There's a really good one focused on some of the septic system impacts in Rhode Island by Cox et al. And they were finding about 14 to 17 centimeter rise per decade. Some of that seemed to be associated with artificial recharge. They've documented this Cape Cod down to Florida, some of these changes. And then our numbers kind of fell in the middle there of the range, around 11 centimeters per decade. Systems that met or marginally met the 0.45 meter vertical separation distance in North Carolina back in previous decades. Now it looks like those systems wouldn't currently meet that requirement. And so when we look at some of these communities, it looks like that area that would be suitable for septic systems now, it's decreasing over time. So we're losing areas that have the deeper groundwater table that would be suitable. And then just thinking about some of the communities that are sort of trying to address this issue now, there's some good examples from Miami-Dade County, St. Augustine, Florida, and then Nags Head. Just some examples of a real detailed study that Miami-Dade County did, just looking at where their vulnerable systems are and trying to look at approaches where they can deal with this. And then when I think about it, just looking broadly at the Atlantic coast, the places where they map out high tide flooding issues, where this corresponds with septic system usage, it's likely that those systems are also starting to feel the stresses of shallower groundwater levels over time. So main conclusions, we could notice that the groundwater levels in the superficial aquifer along the Outer Banks, they appear to be rising with sea level over time. So that's kind of a chronic issue. Also, the storm-related groundwater level rise can limit functionality of these systems more temporarily, depending on when we get these storms. There's a great interest in these areas to look at alternative systems or approaches to retrofit these systems so they can function better in shallow water table environments. One of the challenges is just funding, because these will be a lot more expensive than conventional systems. a lot of coastal communities don't have good on-site wastewater infrastructure databases. So trying to map out exactly where the vulnerable systems are. There's a lot of paper permit information, but not a lot of communities have this digitized yet where you can really look and map these systems out. And just looking at our regulatory approaches in coastal communities where, at least for North Carolina and a lot of other states, the regulations will look at relatively stable groundwater levels when you permit the systems, and they're not really considering what happens if these groundwater levels rise over time. So we would want to have some kind of buffer in there to account for that change. So there's a need to address this with policy and management actions. For our particular study on climate change and systems in the Carolinas, we have a report that's available at the website there indicated. And just thanks everyone for your attention. I'll finish up here with acknowledgements. Thank you.
Thank you, Mike, Dr. O'Driscoll, and everyone for coming. We've got time for questions, so you can unmute yourself and drop right in, or raise your hand, or drop a question there in the chat. Very interesting, Mike. I'll kick one off here just to get the ball rolling. I was intrigued by the Nags Head study and the fact that you were using some GIS numerous times, but to identify the susceptibility of systems, in advance, as well as in hindcasting, in like the clustering of dense systems. That's a threat to, economics, but also water quality. Are there policies that are kind of going in and targeting those areas, whether it's, help with mound systems or hooking up to centralized systems, or is this kind of an aberration in one community? It's kind of way ahead of the others.
Yeah, I can speak a little with Nags Head, which I think they're pretty progressive with this issue. They have some cool programs. Like one program is they'll give you a free inspection, and then they take it off your water bill. So you could get your system looked at for free. The other thing they do is if you have a malfunctioning system, they have a zero cost loan program. So they're helping people out to address some of the failing systems or systems that aren't functioning properly. With respect to other communities, like we've seen St. Augustine starting to do that down in Florida. One of the things that Nags Head has spoken about that they're interested in trying possibly is a subscription service. So basically, you pay in like a utility, and then they would have personnel that are trained to go look at your system. Like every year, they would make sure that you take care of pumping your system out. Since it's decentralized, it really varies how much people maintain their system, and a lot of the properties are rental. So the people that own the home might not really be as familiar with what's going on.
In businesses?
Yeah. So businesses, some of the larger systems, they will be on packaged treatment plants. So once you get to a certain amount of water usage, you start to get over to that. But it's kind of interesting, your point about centralized wastewater management. They've surveyed a lot over the years, and several times when they've surveyed, the community said they don't want centralized sewer. It's a lot more costly. Also, there are some questions about whether the state would permit to have a large wastewater treatment outfall into these sensitive coastal watersheds. But the other thing that came out is if you go to that, then your population density can increase a lot more if you go to central sewer. So there were concerns about that. Like if you have septic systems, you have to have a certain amount of land to have a repair field and your working field.
Yeah.
So it makes it so the parcel size is larger.
Hmm,
If you go to centralized, it would start to lead to denser population.
hmm. Yeah, we got Lauren with a question.
Yeah, I had a question regarding the amount of parcels. Is every single thing in Dare County on septic, or is there any type of city system at all? Is everything septic?
It mostly there are a few small municipal treatment plants, and there are these ones that kind of fall in the middle. It's more the gap is filled more with package plants. So these can be for hotels and restaurants. And some of those can be pretty large. There's a range of those, and there are certain technologies that the state approves. So there are some that are a lot more common than others, but there's thousands of septic systems and there's hundreds of package plants, basically.
Yeah, because I know you made the comment about also having a large waste treatment center like near the bay, but all those unregulated, containers under the ground, like to me, that seems more of a risk.
Yeah, they're spread out.
Yeah.
Yeah, no, it's a debate right now, trying to figure out what makes the most sense. And cost, like one of the things with the Outer Banks is because it's a narrow barrier island,
Mhm.
usually your costs go down in a city if everything is densely populated and the big cost is running the lines. So along a narrow barrier island, the lines
Bottom
have to
line.
be really long.
We're monitoring the chat. Anybody else with a question for Michael? Looking through here, we still have a lot of folks in the audience.
I had another question. Do you think it's possible, like with the increased precipitation we're anticipating with climate change as well, that maybe we could have like small pumps or something in our yard to maybe help mitigate for at least the precipitation? I don't know. What do you think we can do regarding that as opposed to sea level?
Yeah, it's interesting. And NAG said so their septic system challenges are also related to their stormwater challenges in the places
Mhm.
where there's shallow groundwater. So one approach, like at the beach site, I was showing up in the north part of the island, and there's a park site we were monitoring too. They've started to pump groundwater, and they'll pump it up to a higher dune area. And part of the idea is to help give them more storage space
Mhm.
before big storms. But they also thought an additional benefit is it will help the septic systems in that area to work a little bit better. So, but they really have to consider that as the stormwater challenges are linked to their septic system challenges, because it's all related to
Yeah.
the shallow storage that they have. I definitely have heard about, there's another, the next down chain of barrier islands, Bogue Banks, if you know where Atlantic Beach is in Morehead City area. They've also started to do that kind of thing there where they're pumping groundwater down in some areas.
Like I noticed your first image with like the cone of depression. Like I wonder if we should just start like pumping certain areas to bring it down, like way down, and just I don't know. It seems like it's tricky, but also
Yeah,
kind of a
no,
fun problem.
it seems like, so usually in the superficial aquifer, the water quality isn't as good, but you could possibly use that as a water source and
Mhm.
help deal, like you might not be as worried about cone of depression there if it's helping you deal with stormwater issues.
Yeah,
The
exactly.
the other idea is because they are pumping groundwater that's brackish and they have a reverse osmosis plant, and that
Mhm.
will clean everything out. But so one idea could be potable wastewater reuse. It's not, a lot of people are scared of that. There's public perception with that it's started to happen more in really dry areas, but that could be one thing that could potentially be helpful. The costs are a lot higher.
what, to have gray water or
Um,
to install those?
instead of discharging your wastewater to the superficial aquifer where you're having these drainage problems,
Mhm.
reuse it.
Okay.
Mhm.
In the Hampton Roads area, they have HRSD starting a program of re-injecting highly treated wastewater into a deep aquifer. I was wondering if that, I mean, it's very expensive, but I was wondering but you don't have the open ocean discharge issue that apparently some people object to. And I was wondering if they even looked at that.
Yeah, North they have had 2 test sites where they're testing out that aquifer storage and recovery. What I learned about it is like the regulations were stricter to put water back into the aquifer, and there were some challenges. So one of the test sites was in Greenville, North Carolina, and in the particular zone of the aquifer they were pumping it back out from, they were getting some sediment issues. So I think they're still reevaluating that. But the one near Wilmington was more of a challenge. I don't know if you heard about the Gen X discharge, contamination discharge into the Cape Fear. And they were taking some water out of the Cape Fear and recharging. And some of it's been labeled as contaminated from that Gen X discharge. So, but yeah, there are a lot of examples of that down in Florida where they've been trying that approach. So hopefully with some of the testing in North Carolina, they might be more open to that.
Thank you.
Hey, this is Clay Wise. I just wanted to speak to that injection question or comment. What we're doing is it's the same pH as what's in the ground directly under the treatment plant, and then injecting. Right now, it's been like 1 million gallons a day for like 5 years. They're going to be opening up another plant over the James River treatment plant over in the Newport News, Williamsburg area. That's going to be 16 million gallons a day, I think, by next year. And then they're going to go back to the Nansman facility in Suffolk, and that will be turned up to 30 million gallons a day. And so what we're doing is a lot of analysis on not only the quality of the water that's going in the ground, but also at what rate and all that in different wells. And we're definitely scrutinizing it considerably, considering what we've seen in other places. And no one's kind of done that amount, that volume over a large area. And so that's kind of what we're trying to be very pragmatic about.
Thanks.
Good to hear. Yeah, we're watching that one. I think there's a question in the chat. Looks Jim Morrison has one for you. Can you talk about environmental justice aspects? Nags Head can afford to offer 0 interest loans for new systems. Other OBX places can afford to pump to lower groundwater. Not every place has those kind of resources. So what about elsewhere?
Yeah, there's definitely some challenges. Like it shows up with all decentralized water and wastewater management is the bill for any changes usually falls on the homeowner, right? So you can just imagine there can be a lot of disparities there. Even with private groundwater well issues, that shows up too. So trying to figure out some approaches where you can help out communities that can't afford it, because if you have a utility that sort of spreads it out and you can deal with it a little better, but decentralized just by its nature, they're kind of individual homeowners are kind of on their own. There's some pockets where people can get help, but it's not by our coastal counties, it's not set up that way. And just nationally, I think there are some real issues there. They're trying to come up with better ways where typically our bigger centralized wastewater infrastructure, there are more grants and other help that they can get when you're dealing with larger populations. But in the rural areas, it's not as easy to access funds to help on your individual system. So that's definitely an issue.
Very good. Yep. I don't see any others. Okay. Well, I could go on for quite a while, Mike, but I'll have to pay a visit.
It's
Let's
not
keep
the
these
most
conversations.
appetizing.
Yeah, yeah,
Right
I
before
know.
dinner. Yeah.
Yeah. Let's keep these conversations going. It's really great to kind of hear from our neighbors to the south, and we all hope you fare well in the upcoming hurricane season at CSI. We appreciate North Carolina's services down there. Thanks everybody for joining. This is the last seminar of the spring series, and I'm sure I speak for Eileen and we in thanking you for your continual participation, but also any suggestions. Eileen, you have any last words?
No, just to thank the audience and also to thank Mike for a really interesting seminar. And I will say, if you have suggestions for seminar speakers, please send them to me, Tom, or we. And we'll look forward to seeing you again in the fall.
Yeah. Thanks, everybody. And thanks again, Mike. I'll be in touch.
Thank you.